What I want to do in this video is introduce you to the concept of exponents. And all an exponent is a way to show that a number is being multiplied by itself a certain number of times. So here we have the base number 2, or integer, whole number, whatever you want to call it, being raised to the exponent of 3. Okay, so this is referred to as the base. You can say base or just base number or whatever you want to call it. And then the number up here to the top right of the number is called the exponent. This is the exponent. And all this is saying is that, I'll draw it out here, 2 to the power, that's what we say, 2 to the power of 3 is equal to 2 times 2 times 2, right? So, for example, we can do a little bit more. We could say 3 to the 4th power, right? And all this means is that 3 is being multiplied by itself 4 times. And we could solve this. We could see that 2 times 2 is 4. So this right here is 4. And then 4 times this 2 would be equal to 8. So this is just equal to 8. And then we could see here 3 times 3 is 9. 3 times 3 is 9. And then we can multiply these, and then that would be 81. So 3 to the 4th power is 81. And some language that we use I want to introduce you to as well. So when we have just some number n being raised to the 2nd power, we call that n squared. N squared. And you can imagine that if we have some square, and imagine this is a square, probably look more like a rectangle, but let's say that this square has side lengths n. All of the sides are n. So to find the area of this square, we would take n times n. N times n. Sorry, that's not 2. We would take n times n. And as we were introduced here, a number being multiplied by itself is an exponent. And since there are 2 n's here, the answer would be n to the power of 2, or we say n squared. And we also say, let me scroll down more, let's say we have a cube. And once again, this is not going to be the best cube, but I will try. Here. And you can imagine if this cube had all equal lengths, and we called all of the lengths. So we have here the length, the width, and then let's say this here is the height. That would be n. So to find the volume of this cube, we would take n times n times n. And since there are 3 n's, that's the same thing as n being raised to the 3rd power because you're multiplying by 3 of them. This is read as n cubed. N cubed. So if you see a number to the power of 2, it can be, the number raised to the power of 2, or it could be n squared, and then the same thing for 3, except it could be n cubed. And I also want to go over some misconceptions that people have about exponents, right? So let me do this. Get rid of some of this stuff. I'm going to go over some misconceptions, okay? So when people see exponents, a lot of the times that I've seen, they'll see, we can say 5 to the 2nd power. And sometimes what a lot of students will do, they won't really be paying attention, or they just don't understand exponents, and they'll say, oh, this is 5 plus 5, or maybe even 5 times 2, But exponents, they are showing that the number is being multiplied to itself. So these answers are wrong, and it would be 5 times 5 times 5. 5 times 5. Remember, we always need to remember what exponents mean. It's not adding the numbers or multiplying the numbers individually, multiplying the base and the exponent. It's multiplying a number by itself. So we'll do this. If we had 4 to the power of 4, remember that's 4 times 4 times 4 times 4. Not, 4 just times 4, or 4 plus 4 plus 4 plus 4, or anything else. Now I'm going to introduce you to 2 special cases when it comes to dealing with exponents. So let's say, for now, let's just say we have a number n, like usual, and n is being raised to the power of 1. Okay? So all this is going to mean, right, all that a number raised to the power of 1 means is that it's going to be equal to itself. Because you can imagine that it's just n times, well, no other n's. It's just n standing alone. And then we could also have, and we can see this, like if we had 3 to the power of 1, that would just be equal to 3. Um, so really, every number has an implied exponent of 1 on it. I mean, that's just how numbers work. And then we could see n to the power of 0. And this one confuses a lot of students, right? So n to the power of 0, no matter how big or small the number, n to the power of 0 is going to always just be equal to 1. And you'll see why these cases are true when you learn more properties of exponents and just, working with exponents and algebra. You'll see why these special cases are true. But for now, just accept the fact that a number raised to the power of 1 is itself, and a number raised to the power of 0 is 1. So we could say, 500 to the power of 0. Well, that's just going to be 1. We could have, 94 to the power of 1. That's going to be 94. And these cases will always stand true. So just remember these and don't try to, say n to the power of 0 is 0 or anything. Just keep these special cases in mind when working with exponents. Now let's do just a few small examples, okay? So we can say 6 to the power of 2, or 6 squared. That is going to be equal to, let's see, how many times is 6 being multiplied to itself? Twice. So there's going to be 2 6's. And we already know 6 times 6 is 36. So 6 squared is 36. And then we could say 5 to the third power. Well, that's going to be 5 times itself 3 times. So 5 times 5 times 5. And we already know 5 times 5 is 25. And then 25 times 5, we can do that. So this would be, we can do this off to the side a little bit. 25, and then, 25 times 5. Multiplying, that's 25 again, and then 2. 2 times 5 is 10, plus 2 is 12, so our answer is 125. And then we could take 4 to the fifth power, 4 to the fifth power. So 4 times 4 times 4 times 4 times 4. So we know 4 and 4 is 16, times this 4 and 4 is 16. And then we have another 4 here. So 16 times 16, again, we can do that. 6 and 6 is 36. 6 and 1 is 6, and then that's 9. Move down, and then we add a 0 here. And that's 6. That's 1, and then we add. So that is 6, 5, that's 15. And then we carry this 1, and that is 2. So 16 times 16, this is 256 times 4. And then we can do that also. So 256 times 4. 6 times 4 is 24. Carry this 2. 4 times 5 is 20, and then there's another 2 here, so that'll be 22. Remember, we carry this 2 also. And then 2 times 4 is 8, plus this 2 is 10. So our answer to 4 to the fifth power is 1024. So even though this expression was hard, we can just break it up, and exponents are not really as difficult as you think. And let's do this problem. We'll say 18 to the power of 0 times 4 squared times 2 to the first power. And this looks like a hairy expression, but let's just remember our exponent properties. So 18 to the 0th power, well, any number times its, or any number raised to the power of 0 is just going to be 1. So this is 1 times 4 squared. 4 times 4 is equal to 16. And then 2 to the first power, any number raised to an exponent of 1 is just itself. times 2. And then 1 and 16, well, when we're only multiplying, 1 doesn't really matter because it's just going to end up equaling itself when you're multiplying a number by 1, so we don't even need to worry about that. And then 16 times 2 is 36, but we can just make sure that's a 2, not a 3. That is 12, and then that is 3, so 32. So just remember your exponent properties, and exponents are a lot easier than they look. And we are done.